So this is the December flashback. Question 1, which is on sequences. The first question, it says find the sum of all the multiples of 5 between 100 and 300. So I think the first thing I would do here is start writing out the terms. So we want 100, 105, 110, and so on, all the way up to 300. So you can see straight away you're going up 5 each time here, and so it's going to be arithmetic. So the sum formula we want to use is in the formula book, and it's Sn equals a half n a plus l. The reason I'm using that one is because we know the last term is 300. So we know a, we know d, although if we're using that formula there, we could use the other formula with d in it, but this one's a little bit simpler. And we know L is 300. So in order to use this formula though, we still need to know what n is, and same if we use the other formula. So we're going to have to work out what n is somehow before we can work out the sum. So I think the best way to do that, to find out how many terms, I mean, you could just count how many times you're adding on 5 here, but I think the way I would do it is say this is term 1, term 2, term 3. So we want to find out what n is there, how many terms there are. So this would be the first term a, this is the second term, this is the third term, and so the nth term, as you probably know, is a plus n minus 1d from our arithmetic sequence. So if I just come back to this, I'll bring this back in a minute. We need to find n. So we know that this term here, the last term, we know 300 equals a plus n minus 1 d, and we know that a is 100, we know that d is 5. So subtracting 100 away and multiplying out the brackets will give us this. So 205 equals 5n. So n is going to be 41. You might be able to find that a quicker way. That's how I would do it. So now we know what a is, we know what l is, and we know we're trying to find the sum of 41 terms. So we can go back to the formula we had before. Sn equals a half n a plus l. And if we substitute those values in, we find that the sum of 41 terms is a half of 41 times by 100 plus 300. And so that's going to equal 400. Half of 400 is 200. 200 times 41 is 8,200. So that's the answer to part A. Part B, well, B part 1, it does say it's geometric in the question. So it's geometric progression, geometric sequence, common ratio. So R is minus 2/3, and the sum of the first 3 terms is 35. Okay, so I would write that information down. Let's do it down here. So it's geometric. We know that R is minus 2/3. We know that the sum of the first 3 terms is 35. So since this is geometric, the sequence will look like this. The first term will be a, the second term AR, the third term AR squared, and so on. But we do know, since we know that R is minus 2/3, the terms will be a and then minus 2/3 of a and then if we square 2/3, we're going to get 4/9, so we're going to get 4/9a, and so on. So the sum of the first three terms equals 35. So we know 35 is going to equal the sum of this. So that's a plus minus 2/3 of a plus 4/9 of a. Just to get rid of all the fractions, I'll probably just multiply by 9 here. So if you multiply everything by 9, that's going to give you 315 equals 9a. And then that's going to be minus 6a plus 4a. So what's that? That looks like 7a. So 315 equals 7a. And so dividing both sides by 7 would give us a equals 45. So that's the answer to B part 1. B part 2, let's go back and see what the question's saying. I'll find the sum to infinity. So that should be fairly straightforward because we've worked out what a and r equal. So the sum to infinity is a over 1 minus r. So that's in the formula book, and it's gonna be 45 over 1 minus 2/3, which is 45 over 5 over 3. And so just typing that in, so 45 divided by 5 over 3. You probably got that before me. It's 27. Okay, so the answer is 27.